What would you think if I said hackers could take over your application by running an application on the same port without you even realizing? In this video, I'm going to demonstrate this attack, and then I'm going to explain why it works, and then I'm going to give you some commands so that you can go and try it yourself so you can learn how to protect your own applications. So first up, what is a socket and why are we trying to take it over? Well, a socket is essentially a mapping of an IP address and a port number. Together, they make a socket. On your machine, you'll generally have at least two IP addresses. The first one is your local host, or 127.0.0.1, aka localhost, or you'll have a DHCP or statically assigned address, Ethernet address. There is also a catch-all address, 0.0.0.0. That means for everything, so it's listening on everything. And for the ports, you have from 0 to 65535. You then have all of those combinations for both TCP and UDP. So when you start a service, you'll specify a socket, so an IP address and a port number. Now, generally when you start a service, you'll generally say, well, listen on everything, on the everything address, the 0.0.0.0 or star address, and then the port number. The thing is, the more specific the socket is, the higher the priority of response. So if you come across an application that is listening on everything on port 8080, for example, if you specify a more specific socket, as in the address and then the port number, that will gain priority over the actual application. So let's get into a demonstration as to why this is a bad idea and how you can take over an application. So as you can see in this demonstration, I've created two applications. One is malicious and one is the real app itself. So let's have a look at let's have a look at what they are doing. So if we grab for TCP, you can see one is listening on the everything socket with this port, and then the malicious one is running on a more specific IP address, therefore a more specific socket, so therefore that is going to take precedence over the real application. So let's run the real application here. There we go. So it started, and you can see. So it started, and you can see the PID is there. Right. So if we go over to another host here, and we curl that response, you can see hello from innocent web server app, and the PID matches. Now we're going to go and run our malicious application. So this is simple as running this, and you'll see that it's running on the same port and it has a different PID. So now if we go back to our other host and we do exactly the same command, rather than hitting the innocent web server, we are now hitting our malicious server. So just to run this home, let's kill our malicious server and go back very quickly, run this one, and we're back on the innocent web server again. So why does this work? Well, there is an option within sockets to reuse those sockets. There are two types. There's SO_reuse address, which allows you to state that a socket can listen if it is in a wait state. The SO_reuse port allows you to re-listen on a used socket whilst it is in a listening mode. Now, why would you need this? Well, multi-threaded applications such as Nginx actually use the SO_reuse port option. So what we can do here is, if we run an application on the same socket, because we're being more specific, we are allowed to take over the priority of the responses, and therefore our response gets given over rather than the original application. There are a couple of caveats to this attack. First of all, obviously the application has to use the SO_reuse port. It also needs to run as the same user as the original application. With those two things in mind, anything should be possible. If you want to learn more about reusing of ports and these socket options, then I'm going to put a link in the description below so that you can go and read a really great deep dive on this, because this isn't the video for that. Now, some of you may be thinking, well, I want to try this at home, and so I'm going to put in a couple of commands into the description of this video that you can run. One is a normal application that outputs text that you enter into a file. The other one is a malicious version of that, which is running on exactly the same port, and it should show you how this works on your own environment.